Hey, Year 11s. This is just on about last lesson. I wasn't able to. I didn't think I went through completing the square well enough. I think the first lesson I went on it was good, but then the second lesson I tried to talk about fractions, and I think that threw off a lot of students. So what I decided to do today is I'm going to go through doing the questions in exercise 3E, how to complete the square. Now I'm going to do the same pattern for the basic ones, and then we're going to do one where you take out a coefficient, and then we're going to do one where it has a fraction. Hopefully, just watching me do the examples, you start to understand what it means to complete the square. Okay, and then I'm also going to make another video on how to sketch, how to solve for x-intercepts, y-intercepts, because we now want to put everything together. So we learned how to expand, how to factorize, how to read a turning point form. So that means you can read the turning point. And then now finally putting it all together, the point of it all is to sketch a quadratic equation. That's the goal. Okay, and that's exercise 3F. And so that's what we're going to do on Monday. I've given out that worksheet. Now, I'll be uploading that onto Schoology as well, just to make sure that, we've all got the worksheet and we can work with it. I think I might have uploaded it already, but just in case, I'll double check it. But like I said, so today's lesson, so in this video, is just completing the square. And the next video, I'll talk about x-intercepts, y-intercepts, which is going all the way back to Year 9 mathematics on finding x-intercepts and y-intercepts from linear equations. Same drill, just different algebra, slightly different algebra, same idea. Yeah? All right, here we go. Let's have a look at exercise 3E. Okay, so 3E, you can pretty much ignore, if you wanted to, you can ignore that first question. It's just trying to get you to see the pattern. When you expand a perfect square, what are the patterns to it? Yeah, and that's what I was trying to describe. Now, actually, I'll do that. I'll do that here. So just have a look at the first row. You got x minus 1, x plus 2, x minus 3, and negative x plus 3, yeah? I'm just going to do it over here, and I want you to see what we're really trying to do. It's the pattern, yeah? It's a pattern. So have a look. Let's do the first example, x minus 1 squared. Now remember, if I ask you to expand it in the quizzes I've been giving, you're meant to expand it using a squared plus 2ab plus b squared. Yeah, so if you have a plus b all squared, this is the formula used. That's called expansion of perfect squares. Yeah, some of you might still be doing x minus 1 times the x minus 1, and you do FOIL effect. You can do that. I'm just trying to teach you now. The point of learning expansion of perfect squares allows you to do completing the square. Okay, so let's have a look. And this is what I want you to see. The key part is here. That's the key part, right? 2 times AB. Now let's have a think. We're going to follow the rule. It says square A. A is the first term, which our case is x. So I'm going to do x squared. That's the first thing I do, right? And then if I expand it again, it is now plus 2 times A, which is x, times b, which is negative 1. Okay, so that's my a, that's my b, right? And then plus b squared, so b is negative 1 squared, right? This is what I want you to see. You now get an answer of x squared minus 2x plus 1. Now this is very key. This is very key because the reason for completing the square is to factorize something like this one. That's what we want. Yeah, this is factorized. That's called factorizing. But let's say if we covered the red, you didn't see the red section, so you didn't see this at all. Then the question is, how do you factorize this? Okay, or how do you know it's a perfect square? Because currently, this is a perfect square where you have length of x minus 1 times x minus 1. And the x minus 1 squared just means the area of this square. That's what you're really doing. X minus 1 times x minus 1 is x minus 1 squared, right? And that just gives you the area of a square. So if we have a look at this, we've got x squared minus 2x plus 1. The pattern is here. So you watch the pattern. When it's negative 2, this is negative 1, right? It's linked to that. How do we know that? Because twice of negative 1 gives you the negative 2. So if you want to work backwards, see, naturally, if you half negative 2, so if I said take this negative 2 and divide this by 2. Negative 2 divided by 2 is negative 1. And conveniently, dividing it by 2 gives you this term. Because it makes sense. Double negative 1 gives you negative 2. But the cool thing here is that if you took negative 1 and you squared it, because that's what we're doing here, true? We're taking negative 1 squared. That gives us that last term. This is special. This is special. Okay, so this is what we want. This is what we want to know. It's that last term that we want to know. Okay, so I'll do another example. Let's do x plus 3 squared. Okay, then the pattern should give me, if I just expand it quickly, it should give me x squared. So square the first term plus 2 times the 3. 2 times the 3 gives me 6 times the x, which gives me 6x. And then plus 3 squared, which is 9. Yeah, I'm just using this formula up here to expand it. You can look at it again if you want. I'm just trying to show you the comparison here. So here we go. Again, watch the pattern. 6. How did I get 6? It's because I doubled something to get to 6. And we knew from the formula before we did twice 3. So twice negative 1 here gave me negative 2. So I'm going to do the same thing here. Twice the 3 gave me positive 6. Now the nice thing is, if you want to work backwards, if you were only given x squared plus 6x, then what you can do is you can say, well, what if I now divide this by 2? Because you double something to get to 6. So then what if I halve it? Then 6 divided by 2 will give you positive 3. But the special thing is, well, if you have positive 3, then you know the square of positive 3 will give me 9. True? True, because that's what we did up here. We said whatever b is, I'm going to square that and it should give me this. So the nice thing is, if I took whatever this value is and I divide it by 2, I should get b. Once I get b, I can square it to get the last number. Okay? Now, if you're sort of looking at this like, yeah, I kind of get it, but well, what are we trying to do? What's the point of all this? Well, I'll show you what I mean. You see, so now, let's have a look. Let's have a look at the example here. If I gave you now x squared plus 8x, okay, then the question is, what should the last value be if I want a perfect square? See what I mean? So this is what I mean. This is what I'm saying. If I'm following the rule, so let's follow the rule again. What was the rule? It was a squared plus 2 times a times b plus b squared, right? And I know that a squared, which was square this one, and I get x squared. So that's good. I've got the x squared. The question is, what number should this be for me to get 8? Okay, how do I get 8? Now let's go back to the pattern again. So just look at the pattern again. How did I get negative 2? How did I get 6? I got it because I said times the 3 by 2. Yeah, because that's what the formula is. Remember, it's 2 times a times b, right? So 2 times the 3 gives me the 6. 2 times the negative 1 gives me the negative 2. So the question now goes back to this again. 2 times something, what is this number? Should it be double something to give you positive 8? Now hopefully at this point you would have figured out that the number we should have, so the number that we should have to get that 8, the number that has to be here must be positive 4. True? Because square of positive, double positive 4, so double of this, I'm just following this formula, 2 times a times b, yeah, should give me the 8. So that means if that's 8x, what should the last number be? See, the last number is based on whatever this is, you square it. So if you square the 4, you should get 16. True? That is a perfect square. So this is where it's important here. We need to know this is a perfect square. How do we know? Because half of this will give me the 4. Half of this will give me the 4. And then from the 4, I can square that to get the 16. Okay, so you can test this if you want. If you don't believe it, you can test it. You can say, all right, x plus 4 squared just means x plus 4 times x plus 4. True? And then we expand it, x times x squared. Good, that's what we got. Then x times the 4 gives me plus 4x. Okay, and then 4 times the x again gives me plus 4x. See, this is 2 of them. That's why you get 8x. And then 4 times the 4, 16. Voila, you got them all. Okay, so what I'm more interested in the skill that you're meant to be able to do is to be able to see this pattern. That if you half this term, if you half the number in front of x, that should give you this value. But once you have that value, squaring that should give you the last term. Okay, that's the pattern. Okay, so now if you can keep that in mind, just keep that in mind. We're now going to do an example. Okay, I'm going to do an example where you're going to factorize by completing the square. So I'm going to pick out this one here. Okay, so let's have a look. So the aim here is to complete the square. Now, let's have a look. I've got, right now I'm going to do A. A tells me you've got y equals to x squared minus 2 times the x plus the 3. Now, before we even start, you see, we want to factorize this. Now, we can factorize this by what we call completing the square. So, right now, the question is this a perfect square? Is it? You know, like, how do you know? Like, a perfect square would be something like this. Yeah, x, and we don't know what this value is. Now, the question is, what would I have to have? What should this be so that when I expand it, I get x squared minus 2x plus 3? That's what we want. Okay? Now, what you can see is, again, this is a negative 2. If that's a negative 2, then what should this number be in here? Okay, now the number in there, if you think about it, how do you do it again? Let's look at the pattern. It was, if this was 8, how do you get 4? Divide this by 2, because we knew double the 4 gives me 8. So then half the 8 gives me 4, right? So I'm going to follow the same pattern. I'm going to look at this and I'm going to say, well, that means double something here gives me negative 2, or half the negative 2, and it should give me whatever the answer is in this bracket here. And I know that half of negative 2 is negative 1. Okay, so this is apparently x squared minus 2x plus 3 should be this perfect square. But let's double check this. If I expand this, does it actually give me the same equation? So if I expand it, we get x squared, and this is what? Plus 2 times a, which is x, times b, which is negative 1, plus negative 1 squared. Yeah, I'm just using the formula. We had expansion of perfect squares, yeah? That gives you x squared minus 2x plus 1. And that's a bit of a shame because this one has x squared, this one has x squared, this one has negative 2x, this has negative 2x, but this is a positive 3, and that's not a positive 3. So sadly, I don't have a perfect square, right? This is a perfect square. If I was given this equation, then I can say that is a nice perfect square where you have x minus 1 times x minus 1, and the area is x squared minus 2x plus 1. But I don't have that right now. I've got the plus 3, so that's a problem. So when we say completing the square, what we're trying to do is force it. See, I want that 1. That number 1 here is so special. I want that, because if I had that 1, then I can say it's a perfect square. True? Okay, if I had that 1, that's a perfect square. So what I'm going to do is I'm going to say, well, why don't I just put the 1 in it? Why don't I just put in what I want? I've got x squared minus 2x, and I'm going to say, let's put in the 1 that I wanted. Let's put in the 1. Yeah, finally I get the 1, right? But remember, I still have that plus 3 here. The plus 3 still exists there, so I'm going to do plus 3. Now, this is weird because where did the 1 come from? I just shoved it in there just to make it work. So naturally, what we say is we're like, well, what if I put 1, but then I also minus 1? Now, some of you mentioned this in class. You said, what's the point of doing that? Because you're saying like, it's like add 1 and then minus 1. Technically, you've done nothing. So what's the point of doing it? Here's the point. This is the point. X squared minus 2x plus 1. See, this is also x squared minus 2x plus 1. But we know that's a perfect square. We know this is actually factorized to this. See, the point of putting the plus 1 there is that it equals to this. And you're like, but can you do that? Can I just put a plus 1? I'm like, yeah, because remember, you're also minus 1. And that cancels it. It's like saying this is the box, right? And you want to have 3 basketballs in there, right? 3 basketballs, right? But you don't care what color it is. Let's say I wanted a black basketball in there. Then it's okay for me to put in a black basketball, right? As long as I take out a basketball. So I end up having 3 basketballs with the red ones on the outside. And that still works. So I can put 1 in as long as I subtract it. So it's the same thing here. I'm just putting in a 1, but then I'm also subtracting it. So technically I haven't changed anything, right? But nice. by putting that 1, it's nice because I can factorize it, and now I've got 3 minus 1 is plus 2. This is called, this technique from here to here is called completing the square. Okay, hopefully you're starting to get a vibe of like, oh, I think I know what you're talking about. Yeah, I'm going to do the second one. I'm going to do a few more examples so you feel much more confident about it. Yeah, let's do B. Let's have a look. I've got y equals to x squared plus 4x plus 1, right? So same thing again. I want to have a perfect square. The question is this a perfect square? So if it was a perfect square, think about it. It should be x something squared. Now to get the 4, okay, the only way to get the 4 is I had to double something here. Now, if you don't know what that is, you can say divide this by 2, and that will tell you what this should be. So positive 4 divided by 2 tells me it's a positive 2. Now, if this is true, if I expand this will give me x squared plus 4x, and then square the 2 gives me plus 4. This is a perfect square equation, but sadly, that's not what I got. I've got this plus 1. That's a problem. See, that's not what I want. I wanted that plus 4. That's what I wanted, but I don't have that. So what we're going to do is we're going to say, all right, well, okay, what if I just push it in there? So I've got x squared plus 4x, and I still have that plus 1. Yeah, remember that? And I'm just saying, all right, let's put in the plus 4. Because if I got the plus 4, it's great. I'm going to put the plus 4. I'm going to minus 4. So if I add 4 and then minus 4, it's okay. It cancels out. It's all good. Yeah, no issues there. So if I just write it over here so that you can see, if I add 4 and then minus 4, it's okay. I haven't really changed the equation in any way. But the nice thing about this is I now know this is a perfect square. See, it's an x squared plus 4x plus 4, and I can rewrite that as x plus 2 squared. Yeah, and then I've got the negative 4 plus 1, negative 3. That technique right there is called completing the square. Because when I expand it all, it should still give me the very first line. Okay, but this is nice. This is called completing the square. Okay, you're just putting in what you want to make it a perfect square. Because you don't currently have one. Okay, so let's do another one. I'll do C. So have C, you got y equals x squared minus 3x plus 1. Okay. Y equals x squared minus 3x plus 1. Now this one's going to be tricky because it's going to have fractions. Maybe I should do that last. Now I'll do it. All right, here we go. This one a lot of students don't like because it's got fractions, but it's the same technique. Don't freak out. Yeah, it's the same idea. Okay, it's the same idea. So is this a perfect square? Okay, is this a perfect square? Well, the only way to find out is, again, x something squared should give me the negative 3. So think about, not something squared, something double. So whatever this number is, double that number and I get negative 3. Now, hopefully a lot of you sort of figured it out that if you half this number, if you half the negative 3, you should get the middle value. But half of negative 3 doesn't give you a whole number. Half of negative 3 is negative 1.5. Now, I told you in class, don't write negative 1.5 because it's bad habits to work with decimals. I know it makes more sense to you, but you just really got to work with your fractions. Students hate fractions, and you just got to work with it. Okay, so now I know it's negative 3 on 2. So the question is this a perfect square, what I currently have? The only way to know is you expand this potential equation. Okay, so you square it, so you get x squared plus now 2 times a, which is x, times b, which is negative 3 on 2. Yeah, so a squared plus 2ab plus b squared. Okay, and this gives me x squared, and I know a lot of students struggle here. This is minus 3x. And then this becomes plus 9 on 4. Just to help you guys with your fractions, because I know a lot of us struggle with it. How did I get negative 3? Just write it out. 2 times x times negative 3 over 2. Right, now notice these are all whole numbers, so I'm going to write them out of 1, out of 1. Now we can do cross simplification. Remember, 2 divided, this means divide. 2 divided by 2 is 1. And 1, numerator, 1 times x times negative 3 is negative 3. 1 times 1 times 1 is 1. That's why I knew it was negative 3x up there. So that's why I knew the answer is negative 3x, because x times negative 3 is negative 3x, right? That's how I got negative 3x here. And then let's look at the second one. How would I get 9 on 4? A lot of students, again, freak out with a fraction with a square. It just means negative 3 on 2 times negative 3 on 2. That's what negative 3 on 2 squared means, yeah? Negative 3 times negative 3 in the numerator is positive 9. 2 times 2 in the denominator is 4. Okay, so that's the only reason why it looks hard, okay? But here, this is meant to be a perfect square. So I've got an x squared. Yes, I do. Yes, I do. This has negative 3x. This has negative 3x. Yes, but this has a 1. But this has a 9 on 4. See, this is your perfect square. This is what I want. But I don't have a 9 on 4. Instead, I have plus 1. So what do? Force it. Push in the plus 1 that I wanted. So that's what I'm going to do. I'm going to say, all right, I've got x squared minus 3x. And that's the plus 1 that I don't want. In fact, I only want the 9 on 4. So what I'm going to do, I'm going to put in the 9 on 4. But if you put in a 9 on 4, then you also got to make sure you minus the 9 on 4. Because this is a nice perfect square. This should give you the perfect square that we figured out before, which was this one. X minus 3 on 2 squared. So I've got x minus 3 over 2 squared. And then now I know a lot of students struggle with 1 minus 9 on 4. I know the answer is negative 5 on 4. Okay. And how do you do that again? Let's just revise our fractions. 1 minus 9 over 4. Yeah? How do you do fractions again? 1 can be written as 1 over 1. You can't subtract fractions or add fractions unless the denominators are the same. So you times this by 4, times this by 4. And this now gives you 4 over 4, which is still 1, minus 9 on 4. So if you got 4 of these quarters minus 9 of these quarters, well, 4 minus 9 is negative 5 of these quarters. That's why I knew it was negative 5 on 4. If you're wondering how I did it fast, what I did was I did 4 times 1 minus 9. Yeah, 4 times the 1 is 4, and 4 minus 9 is negative 5, and it's over 4. Yeah? But there you go. Up until my step, you see, the pattern's all the same. See, here I put in the plus 4, then I minus the 4. Here I put in the plus 9 on 4, and I minus the 9 on 4. The question is, where did I get the 4 from? Is because I squared the 2. Where did I get the 2 from? Is because I halved the middle term. Half the 4 gives me the 2. Square the 2 gives me the 4, which is what I want. Okay, that's what completing the square is. Hopefully, the basic steps there, you're sort of getting your head around by now. Yeah, I'll do more. I'll do more. Don't freak out. I'll do more. I'll do same thing. Question. Let's have a look at question 3. Let's look at question 3. Okay. Let's look at question 3. I'm going to do the easy ones first because I want to make sure that you're sort of getting your head around sort of how to complete the square and why you complete the square, right? So let's have a look. A, you got x squared minus 2x minus 1, right? So same thing again. You want to complete the square because it says first by completing the square, right? How do you complete the square? You got to make sure that this is a perfect square. Okay, is this a perfect square? That's what we want to know. But the only way to know is if the last term is, whatever it is that it should be. Now, again, how do you figure it out? Again, it should be something squared. We've got the x, okay? But if this is negative 2, how do you get the negative 2? Is because you doubled something here to get the negative 2. Now, or you can do negative 2 divided by 2 and you get whatever this number should be here. Now, I know that if I divide negative 2 by 2, I should get negative 1. But here's the thing, if that is negative 1, then the last value should be a plus 1. Because if you expand this, it becomes x squared plus 2 times x times the negative 1 plus negative 1 squared. And what you can see is this becomes x squared minus 2x plus 1. See that? This here is the perfect square. That's my perfect square, right? Let's have a look. See, this is a plus, this is x squared, I've got x squared. This is minus 2x, this is minus 2x. But this is a plus 1. I don't have a plus 1, I've got a minus 1. So that's where the issue comes in. So I'm saying, all right, you know what? I'm going to have what I have. I got x squared minus 2x. I still had that minus 1. But why don't I force that plus 1? Because I wanted a plus 1, because this has a plus 1. True? That has a plus 1. That would make it a perfect square. This is a perfect square. So we say, all right, well, if I add 1, I'm going to minus 1 as well. Add 1, then minus 1. Yeah? Nice thing about this is a perfect square now. X squared minus 2x plus 1 is the same as this line here, and we know that's the same as this bracket here, so x minus 1 all squared. Then over here, negative 1 minus 1 minus 2. Up until that step, that's called completing the square. Okay, up until that step is called completing the square. In this question here, they're actually asking you to solve because it's all equal to 0. It's equal to 0, it's all equal to 0. And from here, you're meant to do inverse operations. So you can see, you can say if that's minus 2 plus 2 on both sides, negative 2 plus 2 cancels out. You now get x minus 1 squared is equal to positive 2. To get rid of the square, inverse of squaring is square root. So if I square root both sides, the square roots cancel out, and I'm left with x minus 1 is equal to, remember when you square root, plus minus root 2 is your answer. And you don't want that minus 1 there, so you add 1, and so x should equal to 1 plus minus root 2. Okay, that's what they wanted you to do in exercise 3E and question 3A. Okay, but the real step that I'm really more interested in is the completing the square. Okay, let's have a look at let's do C. Okay, let's do C. Same thing again. I've got now x squared minus 6x plus 2, right? Same drill. I know that for it to be a perfect square, so I've got x, bracket, double something should give me negative 6x. Or, the other way of thinking about it is, oh, what is this? Yeah, there we go. Halving the negative 6 should give me whatever this value should be. So, halving the negative 6, I know this should be negative 3. But then if that's negative 3, then expanding it, I should get x squared minus 6x, because 2 times negative 3 times x is negative 6x. And then squaring that last value, squaring of negative 3 should give me plus 9. So I need a plus 9. But the problem is I don't have a plus 9, I've got a plus 2. So what do we do again? Same thing. X squared minus 6x, I still have that plus 2. So what am I going to do? I'm going to say, well, I'm going to add in that 9 because I'm going to force it in. But then I'm also going to minus it because then technically I haven't done anything to it. But the nice thing is you've just changed the looks. And looks is x squared minus 6x plus 9. We know it is a perfect square. So we rewrite that as x minus 3 squared. And you still got negative 9 plus 2. It's negative 7. Up to that step, that's called completing the square. How do we feel? Hopefully that kind of makes sense. Yeah, I've done quite a few examples there. That's 5 examples. Now, the only thing I tried to teach in the last lesson was something like question E, and then I'll do question F, okay? F is not nice because you got fractions, and kids hate fractions. The techniques are all the same. I'll do E first, so you feel a bit more comfortable, and I'll do F so you have an idea of how to do them, okay? So let's have a look at E. I'm just going to move this down so we can start anew. Let's have a look at E. Okay, so E's down here. E, you got 2x squared minus 4x plus 1, right? Now, unlike the ones I've done so far, they all have a coefficient of 1 for the x squared. Okay, it makes it easier to do. So you can see that everything I did, where is it? Let's see. You see, I'm going to highlight what I mean. See this? See this? See this? See this and this. What do you notice for every one of them, which I'll show you? They all have 1. 1x, 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 1x. Yeah, they all have 1x. So when you expand it, it's always going to be 1x squared, 1x squared, 1x squared, 1x squared, 1x squared. So the pattern seems like it only works for 1x squared, and that's true. With completing the square, it only works for 1x squares. So what do you do when you have our case? So even look at this one. See, this is 1x squared, and that's a 1x, yeah? Even with this pattern here is 1x, and you get 1x squared. So what do you do when you don't have a 1x squared, and instead you've got 2x squared? What do? At our case, in this point here, what we do, the first step, and regardless of what it is, you just have to take out 2 as the common factor. So 2, taking out 2, I get 2x squared, 2 times the x squared gives you 2x squared, minus 2x plus 1 out of 2. Okay, because 2 times half gives you 1. True? So now that I've taken out the 2, what's nice is that I've got now a perfect square. I've got 1. See, that's a 1x squared there. And that's what we can do. We can work with these values. Okay, so right now you're just going to ignore it all and you're just going to pretend that's all you have. You only got this x squared minus 2x plus half, right? But is that a perfect square? That's what we want to ask. Now, same thing again. We ask the same questions. If this is a perfect square, what would this middle term have to be? So how do I get that negative 2? What number should this be? And again, same thing. Half of negative 2 should give me this number here. So half of negative 2, negative 1, right? Now, if I expand this, this should tell me what my perfect square should be. It's x squared. 2 times negative 1 times x is negative 2x. Square the last number, positive 1. This should be what I should have. But instead, I've got the x squared minus 2x. I've got those two, but I got a half and I got a 1. So I want that 1. So again, same thing as what we've been doing so far. We want that 1, so we need this 1 here. So how do you do it? I'm going to rewrite the equation again. I'm going to do it in red. So I still have the x squared. I still have the minus 2x. I still have the plus half. What am I going to do? I'm going to say, because I need that 1, I want this 1 to make it a perfect square. So what I'm going to do is I'm going to say, all right, well, let's add 1 then. But if I add 1, I should also minus 1, because then I haven't changed it. This is nice, because this is a perfect square. Okay? Now, just to not confuse you, I'm just going to put back in the green colors. Remember, this is still the bracket there. I still have this bracket here. I still have the 2 on the outside there. Now I'm going to write in the next line 2. See, the nice thing is we know this right here is a perfect square. So if that's a perfect square, this should give you x minus 1 squared. That's what it factorizes to. Remember? Double the negative 1 gives you negative 2x, and then square the negative 1 gives you positive 1, right? But then we still got this one. Negative 1 plus half. Negative 1 plus half. Again, my technique is 2 times the negative 1 and then plus 1. So negative 2 plus 1 is negative half. Okay, so it's minus negative half. There you go. So what I've done is I've completed the square inside the green brackets. But remember, you still got this 2 here, and you got to multiply the 2 to every term inside. I multiply it to this bracket, and I also multiply it to the fraction there. So my answer finally should be 2 bracket x minus 1 squared, because it's 2 times that bracket. And then 2 times, or double the half, is minus 1. Yeah, so you can think of it as 2 times half, and you can see that 2 over 1, 2 divided by 2 is 1, 1, so negative 1 over 1, negative 1. Yeah, that's how I got negative 1. So there you go. This is factorizing by completing the square where you have a coefficient of 2 in front of x squared. Yeah, and that's how you do that. Now I know fractions get tricky, but the technique's still the same. I'm still trying to get that perfect square. Add 1 minus 1. Yeah. Now question F is going to be very similar. So if you have a look at F, 3x squared minus 5x minus 2 equals 0. Oh, forget about the equals 0 for now. Same thing again. I don't have 1x squared. What's the issue? It's this 3. So what am I going to do? I'm now going to take out 3 as my common factor. Okay, and that becomes x squared minus 5 on 3x minus, I know you're not going to like this one, I know, because there's fractions. Okay, I know. Same techniques though. Okay, same techniques. So same thing again, I've taken out the 3. Why did I do that? Is because now I have 1x squared. What I want to do is I want to complete the square of this. Now the only way to complete the square of that is, again, double something gives you the negative 3 on 2. Okay? So, or another way of thinking about it is negative 5 on 3 divided by 2 gives you this number in here. So, this is where I know negative 5 on 3, when you say divided by 2, remember that's like saying 2 over 1. When you divide fractions, it becomes times. Reciprocal, you flip that, and that becomes negative 5 on 3 times 2, 6. So I know this number needs to be negative 5 on 6. Okay? That's how I know, because I know half this number gives you the inside. How do you get that last number? Let's expand this. So if we would expand this, this is x squared. Okay. Now we also know that doubling negative 5 on 6 is minus 5 on 3x. Okay. Now the last number is plus negative 5 on 6 squared. But remember, negative 5 on 6 squared just means negative 5 on 6 times negative 5 on 6, which is 25 on 36. Okay. So what I'm trying to say is the answer is it should be x squared minus 5 on 3x plus 25 on 36. That's what I should have. But what do I actually have? I've got the x squared, I've got the x squared. I've got negative 5 on 3x, I've got negative 5 on 3x. What I have is a negative 2 on 3, which is not what I want. I want the 25 on 36. So how do you do that? Force it in. Yeah, so you're going to just make sure you get that. So you got the x squared, you got the minus 5 on 3x. You still have the minus 2 on 3 here. Okay, I'm just going to do the bracket over here. All right, but you don't have what you want. And what did you want again? You wanted 25 on 36. So that's what I'm going to do. I'm going to say, all right, I'm going to plus 25 on 36. And I'm also going to minus 25 on 36. Okay, because if you add and subtract it, it cancels out. But the nice thing is this is a perfect square. That's what I wanted. That gives me now x minus 5 on 6. All squared. Okay, so this becomes x minus 5 on 6 all squared, and then you have to work this one out. I know a lot of kids just hate this because of the fraction, not the technique. What I'm showing you, a lot of you will understand already. It's just fractions. So I'm going to show you what's negative 2 over 3 minus 25 on 36, and same things again. You need denominators to be the same, so I know 3 times 12 and then 2 times 12. So this gives me negative 24 over 36 minus 25 on 36, and that gives me now negative 49 on 36. Okay, so I know this is negative 49, 36. Okay, and then you got to make sure you multiply 3 to every term. And so now you get your answers 3 bracket x minus 5 on 6 all squared minus, and I know the answer is 49 on 12. How do I know again? Again, fractions. 3 times negative 49 on 36. I can see that 3 divided by 3 is 1 and 36 divided by 3 is 12. And that's why I get negative 49 on 12. Okay, that's how I got the answer. All right, but there you go. So that's how you factorize by completing the square. Please watch this entire video again. The real concept is really looking at the pattern. Okay, it's all about looking at the pattern. Half of this term gives you that. Square of this term gives you the 9. Okay, it's that sort of circle that you're sort of working around. Okay, and that's what you want to get your head around. And then you're working through the examples to do different types. Okay. Start off with that before you do things like H and I, because H and I are exactly the same as F and E. The only difference is it's K. That's all. Instead of like this is a 2, then you take out a 2. If this is a K, take out a K. It's the same concept. It's just more algebra, and a lot of kids aren't really strong with the algebra. Hence why they'll find E, F, H, I difficult, or even G. Yeah. But I just want you to start off by being able to complete the square. Okay, so that's your homework. And I'll make sure that in class we're going to be practicing this for our quizzes every session so that we all can do completing the square. Okay, but I'll finish the video here so that I can then work on to x-intercepts, y-intercepts so that you can sketch a graph. Okay. All right, here we go. Let's